All right, good. So now that we've kind of gone over the external structure of the eye, let's talk about what's inside this eye. We're going to draw another kind of picture of the eye here. Again, we're going to focus on the lateral view. We'll talk about what's inside this eye. So the outer kind of layer of the eye is composed of a pretty thick layer of connective tissue. And I'll kind of draw it like this with this black marker. It's a thick layer of connective tissue, tendon-like material. And this outermost layer of the eye, this is called the sclera. I drew it in black, but that's just to show that it's pretty tough. The sclera is actually composed of a lot of collagen. This is what gives the white of the eye its white appearance, because collagen's white. And it's primarily avascular. That means there's very few blood vessels that pass through it, but there are a couple, and those constitute those little blood vessels that you can see in the whites of your eye. So very few blood vessels, but there are a couple. All right. Now, the sclera is opaque until you get to the very front of the sclera, and I'll kind of color this guy in blue on top of black. All right. So the very front of the sclera is transparent. Okay. This guy is called the cornea. And it's transparent because obviously light can pass through. Right? Light needs to get into the eye, and it passes through the modified portion of the sclera near the anterior side called the cornea. The cornea is interesting because it's actually covered by two little thin sheets of epithelium. You've got one on the outside and one on the inside. The one on the outside is composed of stratified squamous epithelium. This gives it some protection against abrasion. The inside is composed of simple squamous epithelium, and this layer just separates it from the inside of the eye, and it also constantly absorbs fluid from the cornea to keep it nice and transparent. The cornea itself, outside of these two layers of epithelium, the epithelium too, they have no blood vessels going through the cornea. That means it's out of the reach of the body's immune system. That's why corneal transplants are so common. All right. Now, on the just inside of the sclera, we have another layer. This is called the choroid layer. I'm going to draw it in red because it is highly vascularized, and this primarily contains all of the blood vessels that are going to nourish all the layers of the eye. So you've got the good old choroid that kind of wraps around underneath the sclera. This provides all the nutrients for the sclera itself. When it gets to the anterior portion of the eye, it kind of has this little shape. It kind of looks like that. On either side, it kind of looks like that. All right. Let me reinforce this sclera. It's getting a little wimpy out here. Okay. So this choroid layer, highly vascularized, contains a bunch of brown pigments called melanocytes, or melanocytes that create brown pigments, and that helps to absorb the light so it doesn't scatter and mess up the eye's ability to transduce information. So you have this choroid layer. Let me label this guy. So this is the choroid. All right. And then this little part where it bulges out, this is called the ciliary body. And then this part that exists right behind the cornea, that's little rings of muscle called the iris. And that's what allows our eyes to control how much light comes in. All right. Now, the ciliary body is actually attached to a little spheroid-like structure that's transparent. This guy is called the lens, It's attached to the ciliary body with these little tendon-like projections. And what happens here is the ciliary body is actually made out of muscle tissue. And this will pull on the lens and allow the lens to change shape so that light, as it enters the cornea, can be focused on the back of the eye. We'll talk about how that happens in a little bit, but just know that the lens is positioned between the ciliary body. Now the iris is in front of the lens, and this allows us to control how much light comes into the eye. If we were to look at the kind of the frontal view of what's going on here, you would have, I don't know, you'd have a dark cornea in the middle, and then wrapping around the cornea, you would have a series of circular muscles. And this is all part of the iris, circular muscles that wrap around the cornea. When these guys contract, they cause the cornea to get smaller because the circular muscles contract and they squeeze it. And on the outside of the circular muscles, we have radial muscles that are fibers are positioned like that. When they contract, they pull the iris larger. So these two types of muscles are included right here in that iris. Okay, good. Now, on the inside of the ciliary body, we have one more layer. This is called the retina. The retina kind of stretches, starts right here, right behind the ciliary body, and it stretches